This is lesson 2.5 on identifying circles. So last time we talked about the general equation for a circle. If we have a circle with a center at h, k and a radius of r, then the equation that describes that circle is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. And we saw that that just came from using our distance formula. When we think of the circle as being the collection of all points that are a fixed distance from the fixed point h, k, this falls just right out from the distance formula. Now, unfortunately, we are not always going to be given equations of circles in this nice form. Frequently, well, maybe I should say frequently, but sometimes, in this class frequently, we're going to be given equations of circles where everything is already expanded, everything's already squared out, grouped together. It doesn't look like it's in this form at all. So we need to get from this expanded form back into its nice little compact form. And the way that we're going to do that is using a technique called completing the square. Now we saw this technique briefly when we looked at the quadratic formula back in the last chapter. It's going to be the same technique, but we're going to look at it again a little bit more closely, just to make sure that we completely understand how to use it, how to approach these problems. So let's think about this. So if the equation of our circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Let's take a look at what this looks like when we square out each of these binomials. So x minus h squared, remember the way that we quickly square this is going to square the x first. We're going to multiply these two together and multiply it by 2. So I'm going to write like this, minus 2hx, that's going to be x times negative h times 2, plus h squared. So that's what our x minus h squared looks like when we multiply everything out. And then similarly, our y minus k is going to look just like this. Y squared minus 2ky plus k squared. So what I want us to focus on are the x parts and the y parts. So right here are our x parts, right here are our y parts. When we encounter the equation of a circle when it's already multiplied out, we want to group the y parts together and the y parts together and the x parts together. Focus in particular on this number right here, the coefficient of x and the coefficient of y. In order to complete the square, we are always going to have to add some number. What we need to do, the number that we need to add to complete the square, we look at the coefficient of our variable, we're going to divide it by 2 and square it. And so notice here, negative 2h divided by 2 is negative h. Negative h squared becomes positive h squared. So this will be the number that we always add, half of the coefficient of x squared. Furthermore, that number, half of the coefficient of x, that becomes the constant term in our binomial. So we'll see what we mean a little bit more clearly in just a moment when we look at an actual example. But the key thing we want to look at for our x and our y terms, look at the coefficient of x, the coefficient of y, take half of that and square it. So consider this example. So find the center and radius of the circle x squared minus 4x plus y squared plus 2y plus 1 equals 0. So the first thing you need to do, if it's not done for you already, group together your x terms and your y terms. So I'm going to leave myself a little bit of room here, just because I know that I'm going to need to add something in just a moment. So I've grouped together my two x terms, I'm going to group together my two y terms, and my constants, I'm actually going to move over to the other side. So this will become negative 1. So we said before, what we need to add to complete the square here, we're going to look at the coefficient of our variable, we're going to have it, we're going to square it. So we're going to look at negative 4, half of negative 4 is negative 2, Negative 2 squared is positive 4. So I'm going to write plus 4 here. Now remember, when we are working with an equation, we can't just add 4 out of the blue. We're not allowed to do that. If we just add 4 to one side of the equation, that gives us a different equation. So to keep everything balanced, here since I've added 4 to the left-hand side, I need to make sure I add 4 to the right-hand side. Alright, so similarly with my y terms, I need to look at this here, this number right here, the coefficient of y. I need to take half of it, that's going to be 1, square that number, so 1 squared is just 1. I'm going to add that. Just like before, since I've added a number to the left-hand side, I need to add that same number to the right-hand side. So I've always added a number to complete the square. That will always be the case. You will never subtract a number to complete the square in these problems. So now we want to write these as a binomial squared. Our first term is just going to be our variable. Since our coefficient is 1 here, we don't need to worry about what this is going to be. It's always going to be the variable. The number, the second term of the binomial, the constant term, it's always going to be half of the coefficient of the variable. So in this case, we have negative 4. Half of negative 4 is going to be negative 2. So x squared minus 4x plus 4, that's the same as x minus 2 quantity squared. Similarly, with our y terms, we know that the first is going to be y. To find the constant term, we look at the coefficient of y and take half of it. So here it's 2, half of 2 I know is 1. So this is y plus 1 squared. And then finally, for my constants over on the other side of the equation, I just add them up. Negative 1 plus 4 plus 1, that's just 4. So the center, I know then, is going to be 2 comma negative 1. Remember, it's x minus h plus y minus k, so we change the sign of whatever's there. And then the radius is just going to be the square root of whatever number is over here. So the square root of 4 is 2. So there's our final answer. The center is at 2 comma negative 1, and the radius is 2. So let's go through one more example quickly. So here we have the circle x squared minus 6x plus y squared minus 8y equals 0. So just like before, I'm going to group together my y terms and my x terms. Now don't worry that we don't have any constant terms this time. All that means is that this circle actually passes through the origin. We don't need to know that, but we're going to proceed just like we do normally, as we did before when we had a constant term here. So we need to add something here to complete the square. It's going to be half of this number squared. So in half of negative 6, that'll be negative 3. That squared is 9. So I'll add 9 here and here to keep my equation balanced. So what do I add here with the y's? Half of this is negative 4. Squaring that, I get plus 16. So once again, you'll always add things to complete the square. So the whole point of doing this is to write this as some binomial squared. The first term for this is going to be x. The second term is going to be half of this number here. So minus 3. Square that whole thing. Then over here, my first term is going to be y. My second term is going to be half of this number. So minus 4 squared equals 9 plus 16, that's 25. So the center of my circle is going to be at 3 comma 4. And my radius is going to be square root of 25. I know that that is just 5. So once you have this technique down, these are actually not terribly long problems, but we have to make sure that we have everything straight in our head. Otherwise, we're just going to be totally discombobulated with these. One other thing that makes life easier for us is the fact that I'm going to give things to us where the coefficients of x squared and y squared are always going to be 1. If we have the coefficients other than 1, that makes life just a little bit more difficult. One important thing to note, if we are in fact dealing with a circle, and for these problems, if I say it's a circle, it actually is a circle that I've given you. I'm not that evil, just a little bit. But the way that we can tell that this is in fact a circle is by looking at the coefficient of x squared and y squared. If they are the exact same coefficient, then yes, it's going to be a circle. If they are different, it could be some variety of shapes. We'll look at one example here in the application in just a moment. But here the coefficient of x squared is positive 1, coefficient of y squared is positive 1. So yes, this is going to be a circle. If this were positive 1 and this is negative 1, that'd be a completely different shape. If this were positive 1 and this were positive 3, that would be a completely different shape. So the thing that tells us that this is a circle and not anything else is the fact that these two, when they're on the same side of the equation, have the exact same coefficient. In this case, and in every case that we'll see for these problems, that coefficient will be 1. So let's consider this slightly different problem. Find the center of the ellipse 2x squared plus 4x plus 3y squared minus 18y minus 7 equals 0. Now we have not talked about ellipses before. Ellipses are kind of like circles' other less funny cousin or something. I don't know. They're related, but they're kind of their own separate thing. We aren't going to talk about general forms of ellipses or anything, so don't worry about that. But what I do want us to see is that the process of getting it into kind of an ideal form is the exact same process as what we used to get the circle in an ideal form. Now the way that we know that this is an ellipse is notice that the coefficient of our x squared and y squared terms, they are not the same. Here it's 2, here it's 3. However, notice that they are the same sign. So that's how we know that this is going to be an ellipse. The x squared and y squared terms are both positive, but the actual coefficients are different. Now the way that we're going to proceed, let me go ahead and write things out, getting our x's and y's together. So just like with our circle, we're going to group our x terms together, we're going to group our y terms together, and we're going to move our constant term over to the other side of the equation. Now the very first thing that we do, we have not worked with these before where the coefficient of x squared is anything other than 1. We don't want to think about what that's going to look like. So what we need to do is we need to factor out whatever number this is. So in this case we're going to factor 2. Do not factor 2x. Our knee-jerk reaction is to factor out the greatest common multiple, which in this case would be 2x. We only want to factor out the 2. So this becomes 2 times x squared plus 2x. Now I'm still going to leave some space here because I still need to add a number here to complete the square. Similarly, over here with the y's, I want to factor out a 3, not a 3y, just a 3. So when I do that, this becomes y squared minus 6y. And once again, I'm going to leave some space because I'm going to be adding a number here to complete the square. So factoring out a 2 makes 2x squared plus 4x become x squared plus 2x. Factoring out a 3 causes 3y squared minus 18y to become y squared minus 6y. Okay, so when we look at this, this looks nice and just good. We're accustomed to seeing this. X squared plus 2x. This looks just like a circle problem now. So to complete the square, we know that we need to add half of this number squared. So it's going to be plus 2. Sorry, bad math. Half of 2 is 1. 1 squared is 1. Now, we've got to be careful here. Even though we've added 1, remember that everything inside this set of parentheses is being multiplied by 2. So in actuality, we haven't added 1 to the left-hand side. We've added 1 times 2, so 2. To keep things balanced then, we need to add 2 to the right-hand side. If we were to multiply this out, what we've actually added is not 1, but 2. So that's why I've added 2 to the right-hand side. Over here, once again, y squared minus 6y, that looks like what we've been working with this whole time. So I'm going to take half of this number and square it, so that's going to be 9. Now I haven't actually added 9 here, I've added 3 times 9. So to keep everything balanced, I need to add 27 here. So I proceed as before. This is going to be, my first term is x, my second term is going to be half of this number. So x squared plus 2x plus 1 is the same as x plus 1 quantity squared. And then for my y terms, first term will be y, second term will be half of this number, so minus 3 squared. And over on the right hand side, 7 plus 2 is 9, plus 27 is 36. Now, we don't have just one radius with an ellipse. So we're not going to worry about anything like a semi-major axis or any weird stuff that you may know about ellipses. I'm only concerned about what the center is. And in this case, to find the center, it's going to work exactly the same way that it did with circles. So here, the x-coordinate of my center is going to be -1. I'm going to change the sign of the constant here. The y-coordinate is going to be +3. So the center of this ellipse is going to be located at -1, 3. So there is the solution.